Hi, this is Kashif Anod. Today I'm here with a concept in digital logic design which is considered to be very difficult for a beginner like me. But once I have learned it, I consider it a very simple concept and I'm here to share it with you. What is a multiplexer? A multiplexer is a combinational circuit that selects the binary information from one of many input lines and directs it to a single output line. So basically, it is a circuit which selects, which displays an output, a single output from one of in many inputs. One of many inputs. We should remember that a multiplexer has always a single output. That is the basic concept. And the other thing is it can have two, four, or many other number of inputs. So here we will see two examples: 2 to 1 multiplexer and 4 to 1 multiplexer. So how it displays in a single output from two outputs. Let's see. Before that, we will see that what is a selector in multiplexers. Basically, a selector is it is basically the selection line is basically the one who decides which of one input will be displayed at the output. I think I am very clear with my statement that a selection line is the basic doer or selector of one of the input that will display in the output. Okay, so in a 2 to 1 multiplexer, when a selection line is 0, it will it will decide that I naught, the first input, should be at the display, at the output. And if it is 1, it will decide that I1, not I naught or I0, I1 will display at the output. This was basically the theory of this concept. We will see a stimulation which will confirm my statements. This is a selection line, and this is output 1, which we can say I naught, I0, or this, and this is second input, that is I1. So both are these inputs are given. If I give 0 at selection line, you can see here the output. Sorry, I have not connected a logic state here. Sorry for that. So if it is a 0 in the selection line, we see that gate 1 is being enabled. Okay, and we give a single output in the single signal in the output. So if the selection line is 1, it will enable the second gate instead of the first gate. So basically it is a selector how how what signal or which signal will be displayed in the output. So I think I'm very clear with the concept that how a 2 to 1 multiplexer works. Now we can move to a bit not complex but a bigger circuit. It is 4 to 1 multiplexer. It means there should be 4 inputs and single output. Now we can see we have two selection lines. So how to decide for how many inputs, how many selection lines they should be there. So if we say that we have 2 power n input lines, then we will require n selection lines. For example, if it is 2 power 1 means 2 input lines, we should be having 1 selection line. If we have 2 power 2 input lines, we should have n 2 selection lines. So we are using 4 to 1 multiplexers, so we must have 2 selection lines. I think this was the theory. One thing that I should clear here that the inputs are basically high inputs. So there is no meaning for giving a low input here and displaying it on the output. It will be meaningless. So we have we have a high input here. Obviously in binary we have a high and low. We have a high inputs on all of these lines, input lines, and this selection lines will decide which of these high inputs should be displayed on the output. So this you may have saw this table and you must be confused. Why is there I not for 0 0? Why is there I1 for 0 1? So we will discuss it. If we give 0 0 on the selection lines, we decide that I naught or I0 must be on in the output. If we give 0 1 to the selection lines, we decide that I1 should be on the output. And if we give it 1 0 in the selection lines, we decide that I2 should be in the output. If we give 1 1 in the selection lines, we decide that I3 should be on the output. This was a theory. Now let's see its stimulation in the Proteus. I've already given high inputs here to the AND gate, and now we will see that if the selection lines are 0 0, then we have a display in the output, but which one of 4 outputs inputs is displayed in the output, that will be decided by the selection lines. The selection line is 0 0, and we can see here this red line, red point, that this gate U4 is enabled, first gate is enabled, and the signal displayed in the output is basically the input of this gate 1. Similarly, if we give it 0 1, then this first gate is disabled, the second gate is enabled. The same we saw in this table and in this theory. Okay, now if we give it a 1 0, all the other gates are disabled and the input of third gate is basically displayed in the output. You can see from here this gate 3 is enabled. If we give it as 1 1, then all the other gates are disabled and fourth gate is enabled. So basically a multiplexer is a is a is a many input device with a single output, and the selection lines will decide which of one input should be given the path to reach output. This is basically a statement that covers all the concept of multiplexer. Selection lines decide which one of many inputs should be displayed in the output. One of many inputs should be displayed in the output. This was my explanation of multiplexer. I thank you all. Allah Hafiz.